Hello guys and welcome back to my channel Interview with Bunny, and we are back with another video on system designing. And the application that we will be designing today is a chat server like WhatsApp or Facebook Messenger, where the core functionality will be users should be able to send and receive text message as well as the media file from the friends via direct or from the group chat. So this will be the core functionality of this system. So since you guys are already familiar with how the WhatsApp or the Messenger service actually works, so I would not waste much time on explaining the system. Rather, I will jump to the main functionality or the main non-functional requirement that we have to solve over here. So as I have said in all my previous video, system designing is quite a vague interview round where the interviewer will give you a open-ended question like design WhatsApp, and it is your responsibility completely to interact with your interviewer and gather all the functional and the non-functional requirement for the system. So without wasting much time, let's see what can be the functional and the non-functional requirement that we have to keep in mind for designing this system. So the first requirement that we have to solve over here is users should be able to sign up into our application. So as you already know, once we install the WhatsApp application in our mobile, we have to first log in with the help of our phone numbers. Hence, our first requirement would be we have to give the provision for the user for signing in and signing up into our application. Number 2, we have to support the one-to-one message. Number 3, apart from one-to-one messaging, we also have to support some additional thing, and that is the group messaging. So that will be our third requirement of the system. Number 4, users should be able to see all the message history on a particular chat. Number 5, apart from just sending the textual message, we have to give the provision to the user so that he can also send and receive media files such as images and videos. So these are primarily the 5 requirements that we will be solving over here in this video. And apart from that, we have to give some additional features such as whether the message has been sent to our server, whether it is successfully delivered to the person, and number 3, the read receipt of a particular message. So these are the core 5 to 6 functionality or the functional requirement that we will be solving over here in this video. So let's first list down all these functionalities over here. Now let's see what will be the non-functional requirement that we have to solve or keep in mind while designing a chat application such as WhatsApp. So let's list down all the non-functional requirement over here. So as I have said in all my previous video, the first non-functional requirement that you have to gather from your interviewer is the scale of the system. So let's see what can be the scale of this WhatsApp application. So here your interviewer will tell that the total number of users for which we will be designing this system is around 1 billion. So here the total number of users will be 1 billion. And let's estimate that a particular user on average send 100 message per day. So the total message will be 100 message per day, which turns out that the total number of messages that we are supporting on a particular day is 100 billion messages per day. So I hope this is clear that this is the total scale of the system so for which we are developing this application, and you can easily identify that this scale is quite huge because supporting 100 billion message per day is really critical. So if I just assume or just do a rough calculation over here that the total average size of the message including the textual form as well as the video is around 1 KB, then the total number of messages that are getting saved in our backend is around 1 KB multiplied by 100 billion, which comes out around 1 TB per day. So this is the total volume of the messages, both in the form of the textual as well as in the media file that we have to save over here. So here you can easily make an estimation that how critical it is and how efficiently we should design our systems so that we can support this tremendous volume of information. So this will be the first requirement or the first non-functional requirement, and that is the scale of the system. Number 2, what we have to discuss? We have to discuss the CAP theorem. And as you know, CAP theorem tells that whenever you are creating a distributed system, you have to either compromise between the availability or within the consistency of the system. So either your application or the module will be highly consistent or it will be highly available. You cannot achieve both of them together. And here, if you understand our system correctly, our system here should be highly available. Means there should be a zero or negligible downtime so that the user can use our application at any moment of the time. But it should be a eventual consistent system. Means since this is not a bank related application, so here we can afford a eventual consistent system rather than a high consistent system. So it is clear that based on the CAP theorem, here we should give the priority to the availability of the system much more than that of the consistency. So here we will be focusing on the availability rather than the consistency of the system. Now the next non-functional requirement is our system should have a very low latency, because since this is a chat service, the user will expect that the chat will be delivered to the receiver in a negligible time frame. So here the next non-functional requirement will be low latency. And as I always tell you, whenever you are discussing a non-functional requirement during your system designing, always try to quantify it. So here what we are targeting, that our message should get delivered from the sender to the receiver in around 300 milliseconds. So this is the maximum latency we should expect in our system. So that was the third non-functional requirement of the system. Number 4, our system should be highly reliable. Means whenever we are sending a text to a friend or family, we will expect that there will be zero message lost in the system. Means once we send a message to our friends or family, that should get delivered to the receiver with zero message loss. So here the fourth requirement is our system should be highly reliable. So these are primarily all the non-functional requirements that we have to keep in mind while designing our system. So I hope you are clear with that what are the functional and the non-functional requirements that we are trying to solve in this problem. So here you can see we are done with the first step of our designing, and that is the requirement gathering for all the functional and the non-functional requirements. Now keeping in mind all these requirements, now let's start with the second step of our designing, and that is identification of the core entity. So here if you look carefully in all our functional requirements, you can easily identify that what can be the major core entity of our system. So here the first core entity will be the users. Number 2, here we have to support the group messaging. So the next core entity will be the group. And number 3, the most important, and that is the message that we have to deliver to the user. So let's list down all the core entities. So since we are done with the two major steps, and that is gathering of the functional and the non-functional requirement, and number 2, identification of the core entity, let's now jump into the third step of our system designing, and that is the API creation. And as I always tell you, API designing is very easy if you have collected all the functional requirements correctly. So let's see what will be the major REST API endpoints that we need to fulfill all the functional requirement of the system. So let's move to the third step of our system designing, and that is the API design. So the first REST endpoint that we have to give over here, or we have to provision over here, is we have to support the functionality of signing and sign up. So here we will be having two URL, one for the sign up and another for the signing. So let's list down these two endpoints over here. And as you know, while we are registering into our system, means we are submitting a data into our system. So this will be a post call. So the first endpoint will be a register endpoint, and it will be a post call. So this is how the signature of the endpoint will look like. So here you can see this will be our first endpoint, and that is for registering a user into our application. And here in the post body, we have to submit the user metadata, such as the name of the user, the email ID, phone number, and all these things. So here if you are designing a WhatsApp, then here you have to send the phone number as a parameter. Otherwise, if you are creating the messenger application, then there you have to submit the email ID as the post body. So based on the system designing question, that whatever you are designing, mention it accordingly. So this will be the first endpoint of our system. Now apart from this, there will be few more endpoints for onboarding a particular user. Means there will be some added functionality like updating the user metadata, deleting a user metadata, and so on. So here I am just not mentioning all those things, since I have already covered all those things in my previous video. So here also you can keep all those things same. Now let's move to the next endpoint for fulfilling the next functional requirement, and that is sending the one-to-one messaging within our system. So let's see how it will look like. So here you can see this is how the signature of one-to-one messaging will look like. So here if you look carefully, I have not mentioned a post or a get over here. Rather, I have mentioned a WS. And what it stands for? WS stands for WebSocket. So here in any chat application, whenever you are having a conversation between two or multiple friends, here the way we send the text message or the videos in near real time is with the help of the WebSocket. And why we do not use a plain HTTP call, that we will discuss it later, that why it is not advisable to send or receive a text with the help of a HTTP call, rather why we are using a WebSocket for doing a conversation. So I will explain those things in detail while we will be doing our high level design. So let's move to the next requirement or the next API endpoint that we have to design to send the one-to-one messaging, and that is the chat history. So whenever a user will try to see all the previous chat, so we have to give a provision to the user to see all those list of chat that he had done in the past. So for that we will be having one more API endpoint, and that is to see all the chat history. And since here we are retrieving data from our server, so this will be a get endpoint. So let's see how it will look like. So this is how the endpoint will look like. So here you can see in the signature, we are sending the user ID as one of the parameter, and in return, we are sending the list of chat that we have for this user ID. So it is like once we log into our WhatsApp application, we can see all the list of chats that we have done in the past. And once we click on a particular chat or a particular group, thereafter we can see all the list of messages within that chat or within that group. So here this first endpoint will list down all the chats that you have done in the past. I hope this is clear. Now the next endpoint will be once the user clicks on a particular chat, we have to show all the text messages that are there for a one-to-one messaging. So the third endpoint will look something like this. So here you can see this is how it will look like. And here also this will be also in the form of the pagination. But remember, this pagination will be a bit different. It is not a pagination that you normally show in a web view, because there you can see we have to click on 1, 2, 3 to go from one page to another. Rather here it will be in the form of the lazy load. Means once the user scrolls up all the text messages on a particular page, then we have to send the next offset, and thereafter we will get the next frame or the next block of the text messages in the reply. So here remember, this will be a lazy load rather than a normal pagination that we do for our web page. So I hope we are clear with what are the API endpoints that we need to implement one-to-one chat messaging functionality. So I hope this is clear. But here if you look carefully, I have not created any other endpoint to support the functionality like to receive the delivery and the sent receipt of a particular message. Means whenever you see that a message has been sent, you get a single tick. After that, once it gets delivered, it gets double tick. And once the receiver reads that message, it gets a blue tick. So here to implement those functionality, we are not exposing any REST endpoint over here, because all those things will be done with the help of the WebSocket that we will be opening between the two users for the conversation. So I'm not mentioning it over here. Now let's move to the next endpoint, and that is to support the messaging functionality for the group message. And the first and the foremost thing that we have to do is we have to give the provision to the user to create a group, add members to the group, and all these things. So let's see what are the major endpoints that we need over here to create and manage a particular group. So let me list down all those endpoints over here. So to manage and create a particular group, here these are the list of endpoints that more or less you need. So here the first one is to create a particular group, then we have to add member in that group, and then we have to give the provision to remove a user from that group. So these are more or less the major endpoints that we need for the group management. Now since we have created all the groups in our application, now let's see what are the endpoints that we have to give to the user to do a conversation within the group. And similarly over here also, to do a conversation within the group, we have to open a WebSocket. So here also we will mention the same thing, and that is we need a WebSocket for doing a conversation. And number two, we have to give the provision for the user to see the message history. So here there will be one more endpoint to see all the messages on a particular group chat. So let me list down the signature of that endpoint over here. So this is how it will look like. So here you can see we are sending the group ID in our API endpoint, and we are trying to find out all the list of the messages that are present in the group. And this will also come in the form of the pagination or in the form of the lazy load. So these are the two endpoints that we need to do a conversation within the group. So here if you can see, we are almost done with all the major endpoints that we need to implement all this functionality. And as I've already told you, I have not exposed any endpoint to fulfill this requirement like delivery receipt and the read receipt. And number two, for sending the textual and the media file, because both of them will be done with the help of the WebSocket. And this we will explain in detail when we will be doing our high level and the low level designing of this system. So I hope we are done with the 3 steps of our designing, and that is first one, gathering of the functional and the non-functional requirement. Number 2, identification of the core entity. And number 3, the creation of the REST endpoint that are required to fulfill all the major functional requirements. Now let's go to the next step of our system designing, and that is the high level designing. So the high level designing of this system is also quite simple and straightforward, because in the high level designing we only try to fulfill the functional requirement that we have discussed over here. So let's see what were the components that we need to design our system. So the first and the foremost thing that we need is the user. So here we will be designing some of the users, which are nothing but some of the applications that are installed in our phone. So these are some of the clients for us. And obviously, since here if you have seen, we are supporting a scale of 1 billion, and obviously to support this amount of huge traffic, we obviously need a load balancer and API gateway to manage our traffic. So here we will introduce our next component, and that is a load balancer and a API gateway. And the primary role of this load balancer and the API gateway will be authentication and authorization, rate limiting, and distributing the traffic uniformly across all our backend server. And for that, we will be using the round robin approach. So let me mention all those functionalities or responsibilities over here. Now, if you see, the first requirement that we have to fulfill over here is the user should be able to sign in and register into our application. So here we will be having our first service called as the user service, and the main responsibility of the user service will be onboarding the user into our application. So here we will be having our first service called the user service, and since here we have to save the information of the user into our application, so here we need a database called as the user database. So here we will be having our database here called as the user DB. I hope this is quite clear and straightforward, because this is the same design pattern that we have followed in our last 7 videos. So here our traffic is coming into our load balancer, and here the user service will persist all the information in the user DB. So I hope this flow is clear. Now the next functionality is like we have to give the provision to the user to send the textual form of the message, and to support that we need a chat server over here. And for that, I will be introducing one more service and maybe the primary core functionality of our system, and that is a chat service. And it is quite obvious whenever we are sending something to our chat service, that information should be saved into the database. So here we will be having our next database, and that is called as the chat DB, to save all the chat in our backend. So this will be our next database called as the chat database. Clear? Now if you look carefully, here what we are telling, we have to support both the textual form of the message as well as we have to support the media file. And obviously, you know, we cannot save a media file into our database. And as you know, to save all the media files into our application, we use a blob storage or a S3 bucket to save all those data. So here all the textual form of the message will go into our chat database, and all the media file, means the image or the videos, will go to our second storage, and that is a blob storage over here. And thus here you can see we have more or less fulfilled few of the functional requirement of our system, that is onboarding of the user, and number 2, how the user will send the textual message as well as the media file with the friends and the family. So 2 of the functional requirement are already solved. Now the next thing is like we have to support the group messaging, and since I have already told you, the group messaging will also follow the same path, and that is with the help of the chat server. So we do not have to do anything explicitly, rather what we have to do, we need another service to manage all the groups. So here we will be having one more service called as the group service. And the main role of this group service will be to manage all the groups that are there in our system. And for that, we also need an additional database called as the group DB. I hope this is clear. So here you can see we have more or less fulfilled all the functional requirement that we have gathered over here. Now, since we have more or less identified that what will be the core entities or the core module of our system, now let's go into a deep dive analysis and let's see how this individual system will work over here and how they will interact with each other. Because obviously here you can see I just have given a very brief introduction that there will be a chat server which will be responsible for sending the chat from one user to the another. But believe me, this is not at all simple as it looked like, because there are tons of concepts and many things that you have to design in detail to fulfill all the functional as well as all the non-functional requirement of this designing. So without wasting much time, let's go into the next phase of our designing, and probably the most important phase of our designing, and that is the low level or the deep dive designing of our system, where we will see in detail that how each and every component will interact with the database, how we will be sending a message from one user to another in near real time, how we will be sending a confirmation message to the user, means whether it has been read or it is still pending to be delivered. All this thing we will be seeing in our next phase of our designing, and that is the low level designing or in the deep dive designing of this system. So without wasting much time, let's go to the fourth step and the last phase of our designing, and that is the low level designing of this system. Before proceeding further, I just wanted to notify that I have created a very simple website over here so that you get all the contents that I upload on the YouTube on a single platform. So here you can see there are lots of content on the system designing, on the low level system designing. Similarly, here we have the complete graph playlist where we have already 15 to 16 video over here, as well as all the latest contents that I'm uploading on the YouTube. I will keep on updating all those things in this website. This is a free website that is hosted also in a free domain. So do not forget to bookmark this website so that it will be helpful for you to find out all the relevant contents regarding your upcoming interview. So let's start with the low level designing. But before starting the low level designing, I just want to tell you I might sound a bit different now because I just had a root canal and a wisdom teeth surgery. So I sometimes sounds a bit different. I know that, but let's do it. So yeah. So let's start with the low level designing. So here, if you look carefully, in the high level designing, we have given a very brief introduction and we have just identified that what are the major components that is needed to serve or to fulfill all the functional requirement that we have listed over here. But in our low level designing, we will go in detail on each and every component and we will try to see how each and everything will behave and how we will handle this huge amount of traffic with this huge amount of data in real time. So without wasting much time, let's start with the low level designing. And the first thing that we will do, we will just copy paste the same high level designing from here into our low level designing section. So the first thing first, we will start with the easiest one, and that is the user service. And if you have already followed my previous video, you must be knowing that this user service is mainly responsible for registering a user into our application, as well as whenever a user logs into our application, we do an authentication based on this user DB, and in response, we simply give a JWT token or a session ID so that it can call all the APIs that we have designed over here. So here also it will be the same thing, that is here we will be having our user service, and as you know, we have to persist the data of the user, and for that we need a user database. And here also, since the user data is a flat relational data, and that is why we will be going with a Postgres or a MySQL database. Both of them will work the same. Only thing is like it is easy to scale up the Postgres database with respect to the MySQL database. I hope that is clear. So what we will do here, this database will be our Postgres database, and let's see what will be the schema structure or what are the attributes that we have to save over here. So these are the following attributes that we have to persist for a particular user, that is the user ID, username, email ID, phone number, status, last seen, and other metadata that is required. So here remember, if you are creating a WhatsApp, then you do not need an email ID over here. But if you are creating a messenger service, at that time you need an email ID to do the registration. So based on the application that you are getting during your system designing, just create the schema structure accordingly. Here I have just shared a simple generic schema structure that will work for both the application. I think this is quite straightforward and clear. Now let's move to the other services that we have. So here we have the chat service. We will do it later because this is the heart of our application. So the next service that is required is the group service. So the group service is also quite simple. That is, it is a service that is responsible to create and modify a particular group. So for example, whenever you are creating a group or changing any metadata of the group, this service will come into play. As well as there is one more additional functionality that this service is responsible is, for example, you are passing a particular group ID, it will show you or it will return what are the list of members or the user ID who are present within the group. So these are the 3 or 4 functionality that this group service will be doing. And to save all the metadata of a particular group, we will be simply using another database, that is a group database. And here also, since it is a flattened database and a relational database, that is why we will be using a Postgres solution over here also. So let's see how the schema structure of the group database will look like. So this is how the first table of our group database will look like. So the first database is like the group DB, which will have the group ID, the group name, the description and other metadata that is required. Means when was the group created, or maybe the thumbnail of the group. All those things will come as a metadata over here. Now the second table that we need within this group database is the mapping table, means which will give us the information that which user belongs to which group. So there will be another table within this group database, that is the group mapping database. So let's see how the schema will look like. So this is how the schema of the group mapping database will look like. So here you can see we are having a ID, which is an auto increment ID, a group ID, a user ID, the join date and other metadata that is required. So here you can see group ID is not the unique key over here, because you can see a particular group can have multiple users over here. So there will be a lot of repetition of the group ID with the corresponding user ID who are part of the group. So to keep that row unique, we are using an auto increment ID, and that is a simple UID or a simple ID. So here we are done with the 2 tables, that is the group DB and the group mapping DB. So here we are done with the 2 major service, that is the user service, which is quite simple, and the second one is the group service. Now let's move to the next service, and that is the chat service, which is the main core of our application. But just to give you a heads up, there will be some additional service that is also needed over here to fulfill all our requirements. But since we do not know as of now that what are the additional services that we need, so we will not discuss it as of now. But as we progress, we will keep adding all the services that is required. So now let's go to the next service, and probably the most crucial service, and that is the chat service. Now before designing this chat service, let me give you a small concept of what are the different types of connection that we use in our system designing or in the real world application. So as you know, whenever you are calling a particular service using a load balancer, means with these simple approaches, there we use a HTTP connection, means we send a request to the server and in return the server gives you some response. So that is a unidirectional communication which is called as a HTTP connection, means you can only send a request from the client to your server, and the only functionality that a server can do is just to give an acknowledgement or a response in return. Now the second type of connection is like the long polling, means the client make a call to the backend server, and if the response is not present in the backend system immediately, a connection is kept on hold, and once the data is received by the server, at that time the response is given through that connection. Means there is an open connection that gets established between the client and the server in case of the long polling connection. So the first one was the HTTP connection. The second one is the long polling connection. where a client makes a request to the server and it waits for the server to give a response in return for a predefined amount of time. So that is the concept of the long polling. So here we are having a small duration of an open connection in the long polling communications protocol. So that is the major difference between the HTTP and the long polling communication. Now the next type of communication that is possible is called as SSE, that is server sent event. This is also a unidirectional connection, but only difference between the HTTP connection and the SSE is like for HTTP, a client can make a request to the server, but in case of SSE, a server sends a response to the client. So it is like a pushback notification that a server sent to all the registered clients. So that is the difference between a HTTP and a SSE connection. So for example, there are some processing or the event that are generated on the backend. At that time, to send a notification to the client, this SSE comes into play. Means the server sent a notification to the front end that some data are available in our backend, and based on that, all the subsequent calls are done. Now the next type of communication that is present is called the WebSocket connection. And the main advantage or the behavior of this WebSocket connection is it is a full duplex connection. Means a connection is persistent between a client and a server for a long time, and whatever the data that gets generated in the server can be sent to the client in real time. Means there is no waiting time for the client to send a request to the server. Similarly, there is not a delay for the server to send the response to the client. And since this is a duplex connection, means this sending and receiving of the message can happen at the same time. So this is a very important knowledge that you have to know for designing this system. Now let's see what can be the appropriate connection protocol that we will be using to implement this chat service. Now if you look carefully, the chat what we do is on the real time. Means you are typing some messages and you are just sending to your friend. Similarly, your friend is giving a response in return. So there is a bidirectional connection that is happening on a real time. Now if you look carefully, if we are going with a HTTP connection, what will happen? To send a particular message from the client to the backend, what we have to do? We have to simply send a request from the client to the backend service using a post call, and thereafter to get the response for that message, we have to again make a HTTP GET call to retrieve the response from the friend. So each and every time you are posting something in our backend, means you are sending a message, thereafter you have to keep on retrieving the data with the help of the GET call for an infinite amount of time. Means to get any response from our friend, we have to send n number of HTTP GET requests to get all the messages. So that is actually not possible in the real life. Means for example, your friend is not replying you, then there is no reason of sending a HTTP GET call to get the response, because in the server side there is no data for you to fetch. So that will be a simple unnecessary GET call that you will be doing to retrieve the data, and that is why we cannot go with the HTTP connection. I hope this is clear. Now the next thing is like the long polling. So here if you look carefully, we can go with the long polling approach. So here what will happen? So for example, you want to send a text to your friend, you will simply submit the data to our server or to our backend with the help of the HTTP call. So a simple post call will go with the help of a HTTP post call, and it will get submitted to the database. And to get the reply of your friend, what we will do? We will simply do a long polling. Means we will simply open up a connection for a particular amount of timeline, and if within that timeline your friend replies you back, then those amount of information will come in response and it will be shown into your UI. So that can be done. But look carefully, if we are going with the long polling approach, there is a very critical problem that will happen. So for example, you do not know that after how many amount of time or at what time your friend will reply. So it is not possible to open up a long polling session for an infinite amount of time. So for example, a long polling connection will remain persistent for 30 seconds. So you cannot do that For first 30 seconds, you will open up a connection with the hope that your friend will reply within that 30 seconds. Now again after 30 seconds, it will terminate. Then again you have to send one more request with again the same hope that he will reply within 30 seconds. So in this way, there will be multiple requests that will go from the front end to the back end, and all this connection will be open until and unless you receive a message from your friend. So this connection is also not possible in the real life scenario. Now comes the third one, that is the SSE connection. So this one can also be done. So let's see what can be the pros and cons for this. So to implement a chat service using a SSE connection, what you have to do? You have to simply send the message with the help of the simple HTTP connection with the help of the post body. And once you send the message to the server, as soon as your friend replies you back, a simple notification will come from the backend to the front end with the help of this SSE connection. Means a notification will come up that you got something in your mailbox, and thereafter you have to again make a call to your backend to fetch that information. So here you can see you are making at least 2 to 3 calls to send and receive a message from a friend, which is also not possible in the real life, because opening up this much amount of connection for an application which handles a billion of users is actually not possible. So the last but not the least, we have the WebSocket connection. And here what happens is like, since the WebSocket is a bidirectional connection, means at a particular event of time, both you and your friend can talk simultaneously on a single connection. Means you do not have to check repeated number of time that whether there is a data in the backend or not, or you do not have to do a separate HTTP connection to send the message, and then you do not have to wait for another reply from the server. So it is a single connection that will serve both the purpose of receiving and the sending of the text message from you and your friend. So that is why here we will go with the WebSocket connection to implement the chat service that we have to design over here to serve all the text messages in near real time. I hope this is clear that why we have to go with the WebSocket connection rather than a simple HTTP or a long polling connection. So I hope this is clear. Now since you have understood that why we are going with the WebSocket connection, let's now see how we will do it. So what we will do, we have to get rid of this one and we will just create a WebSocket service out of this one. So here we have the chat service which is running on a WebSocket connection. And obviously, since this is a microservice application and we are supporting millions of users over here, so it's quite obvious that there will be a lot of replication of this WebSocket service in our backend. So let me create 1 or 2 applications over here. So this will be all our chat service. And obviously, when we are having multiple service in our backend, we need a load balancer or a API gateway to handle that. And for that, what we need a dedicated WebSocket gateway or a WebSocket load balancer over here. So in modern technology, more or less all the load balancers that are available in the market support both HTTP as well as the WebSocket connection within the same load balancer. But since here our chat service is highly dependent on the WebSocket connection, so it is highly recommended to have a simple dedicated load balancer that only support the WebSocket connection. So what we will do here, we will create one more load balancer or a WebSocket gateway to handle this functionality explicitly. So here we will be having a simple load balancer which will only support the WebSocket connection. And the responsibility of this load balancer will be same, that is the authentication and authorization, the rate limiting and proper routing. So let me list down all those things over here. I hope this is clear that why we have segregated these 2 load balancers, one for handling the HTTP request and one for handling the WebSocket connection. Now what will happen, all these user or the client which are present over here will talk to both the gateway that is present. That is the API gateway and this WebSocket gateway. And how they will communicate? Based on the API endpoints that we are providing. So here if you look carefully, whenever we were doing the API designing, here all these calls that we have defined are post and get, and all of these are normal HTTP call. But here when we are sending the message, this was a WebSocket connection, and whenever there is a WebSocket connection, the connection will go through this WebSocket gateway. So what will happen? All the clients or all the user will chat with each other with the help of the WebSocket connection and through this WebSocket API gateway. So all the connection over here that is present over here are basically a WebSocket connection. Now what will happen? Once the request comes to our gateway, it will simply route the traffic to the corresponding chat service. But remember, this is not at all easy the way it looks like. Because of the fact, if you remember, I told you a WebSocket connection is a duplex connection and it is an established connection. Means it is like a path or a highway that will be open until and unless you are done with your chat. So for example, you are using the WhatsApp for 1 hour, means that connection should be open for 1 hour. And to establish that persistent connection, this WebSocket have to be super intelligent. So for example, whenever the user 1 is trying to chat with user 2, so user 1 have to open up a connection with the chat service 1. Similarly, a user 2 always have to open up a connection with the chat service 2. And if this connection is not persistent, then what will happen? The delivery of the message will fail. So we will discuss all this thing in detail and we will see why a sticky network or a sticky connection is needed over here to establish a WebSocket connection. And we will also discuss how we will do that. Now let's move to the next phase, that how the communication will start. So what will happen? So let's take an example. This is user 1. And this user 1 want to talk to his friend, which is user 4. So what happens is like whenever the user 1 logins to our application, a login authentication request will go to the user service. Means he want to start a new chat. And here, once the credential is matched and the request is authenticated, this user service will send a JWT token or a session token to this user 1. So what actually happens is like once a client or the user want to start a conversation, he have to first request for a WebSocket connection. And how it is done? Our initial HTTP request will go from the client to the server. Means it is a simple HTTP request that will come to this load balancer. So a request come from the client to the server with a request that I want to upgrade my HTTP connection into a WebSocket connection. So by default, you cannot open a WebSocket connection. So to get or acquire a WebSocket connection, what you have to do? First, you have to ask for a WebSocket connection, making a simple HTTP call. And once the request goes to the server does a validation and handshaking. And once this acknowledgement or the handshaking is done successfully with the server, thereafter only a bidirectional WebSocket connection gets established. Means at step 3 only you can send and receive message together. But before that, it is simply a HTTP call that you are initiating. So the real fact is all WebSocket connection are basically a simple HTTP call at the very beginning. And once the handshake has been done, then that HTTP call gets upgraded to a bidirectional WebSocket connection. So I hope this concept is clear that what is the difference and how a WebSocket connection gets established. Now comes to the next thing, that is how we should persist this WebSocket connection and why it is needed to have a sticky WebSocket connection. So here what will happen, once the user have done the handshaking and everything, he or she is ready to send the text to his friend. So what he will do, using that WebSocket connection, he will simply send a message to his friend. So let's take an example that within this WebSocket connection, he is making a request called as send. And here, for example, the user is passing 3 things. That is number 1, the message you want to send. Number 2, the originator, means who is sending the message. And the next parameter is who is receiving the message. Means for example, I'm sending the message from user 1 to user 4. Then the third parameter will be user 4. Means this message is dedicated to user 4. I hope this is clear. So a text message got sent from user 1 to user 4 and this is the message that got sent. Now remember, I told you each and every user is connected to different chat service. So for example, user 1 here is connected to the chat service 1 and user 4 is connected to chat service 2. So here the chat service 1 first have to know that where this user 4 is located. And based on that, it will forward that message from chat service 1 to chat service 2. So there should be a mapping between the user ID and the chat server where it is connected. I hope you got the idea that why we need a sticky or a one-to-one communication over here. Still, if you do not understand, do not worry. As we proceed further, it will be damn clear for you that how we are doing it and why it is needed. So what we have to do, we have to create a mapping between the user and the WebSocket connection it was earlier connected or it will going to connect. So what we'll do, here we will simply create a mapping object. So here the user 1, for example, is connected with an open connection, that is the WebSocket connection 1. Similarly, the user 2 is connected to another WebSocket connection, that is WebSocket connection 2, and so on. So in simple terms, just understand like this. To start a conversation within the WhatsApp, first thing that you need is a WebSocket connection object. So this is nothing but a connector object that is required to start any conversation within the WhatsApp. Until you are active in the WhatsApp, this connector should not die. So that is the main fundamental thing that you have to remember. Now the question is how we will save this information. So here if you look carefully, what is happening is like user 1 is trying to do a chat with user 4. So what will happen? It had already opened up a WebSocket connection, and here this chat service have received the message from user 1. Now this chat service will try to search over here that in which open WebSocket connection where user 4 is connected to. And for that what it have to do? It have to make a request into this mapping object and it have to locate where this user 4 is actually located. And as soon as it find that the user 4 is connected to WebSocket 2, then what it will do? It will simply send the message from the chat service 1 to the chat service 2. And this chat service 2 will simply send that message from this chat service to user 4 using the simple WebSocket connection that is already opened. I hope this is clear that how the communication is getting established and how we are sending the message from one WebSocket connection into other. Now the thing is like how we should store this message. So here if you look carefully, for each and every message that you are sending, we have to scan this entire object, and to make it efficient and provide less latency, we will keep it in a cache service called as a Redis cache. So all this information about the connection, we will keep it within our Redis cache over here. And this is nothing but a WebSocket registry that we are creating over here. So if you just go through the documentation of all the WebSocket connection, you will see that each and every WebSocket connection or a ecosystem will have a WebSocket registry where it have to persist the information that which user is connected to which WebSocket connection. So here we are establishing that only. Now, as I have told you before, the way the traffic is sent from the WebSocket gateway to this chat service, though looks simple over here, it is actually not simple. Because, for example, the user 1 is connected to the WebSocket connection 1. And in between, somehow this WebSocket connection gets terminated or it gets disconnected, maybe because of the network. Now, when the second time this user 1 wants to establish the connection with our backend service, means with the load balancer, this load balancer have to send that user 1 to that web connector it was opened earlier. So this WebSocket gateway will also talk with this Redis cache or with this WebSocket registry to see that which user is connected to which WebSocket connector. So here the gateway is intelligent enough to route the traffic to the corresponding WebSocket server where it requests to send. Now the question might arise that, is it possible to keep all this WebSocket connection open for an indefinite period of time for each and every user? So for example, here we have assumed that we have 1 billion user over here. So it is obviously not possible to open up 1 billion WebSocket connection into our backend, because believe me, WebSocket connection is very heavyweight and it consumes a lot of bandwidth and memory. So it is not possible to open up 1 billion WebSocket connection over here. So what we do here, for each and every open WebSocket connection, there will be a TTL present over here. And TTL means time to leave. Means if you are not active in our system, means if you are not active in the WhatsApp for maybe 1 minute or so, this WebSocket connection will get deleted from this WebSocket registry. And that is why here we have to provide a TTL for each and every WebSocket connection that is open and present within our WebSocket registry. I hope this is clear. Now the next question will arrive is, for example, two friends are chatting over here. User 1 is chatting with user 4. Now, suddenly in between, user 4 dropped off or its network got disconnected. Then what will happen? After a minute or so, this open WebSocket connection will get deleted from this registry. Now again, after a few times, once the user 4 comes to our application and resume with the conversation, what will happen? Another request will go to the WebSocket service over here. And at that time, it will see that there is no predefined open WebSocket connection that is present. So what will happen? A new connection will get established over there, and that new connector will get registered within our WebSocket registry. Now, there is a critical problem with this approach. That is, for example, these two friends are chatting with one another. Now, user 1 sends a message and user 4 logs off, or maybe, for example, user 1 just want to send a textual message to user 4 who is offline. So here what will happen? A request will go to this chat service that I want to send a message from user 1 to user 4. And this chat service will see that user 4 is not active in our system, or there is no WebSocket connector that is already present over here. So what it have to do? Then at that time, to handle all those offline user, it have to persist that information into our database, so that once the user 4 comes active in our application, at that time we can send that message to user 4. So here what we'll do? Here we have to submit all our data into our database. And how we will do it? So since here we are having thousands of requests submitted in our backend per second, so it is not possible for a particular server to persist all those information in our DB. So for that, what we need? We have to go with the approach of the event-driven service, where we can push all the textual messages that we have received from the user. So here basically we need an event streaming platform where we can submit all the data that we are getting from the front end to the backend. So here what we'll do, we need an additional service that is nothing but a Redis stream. Now here you can see we have multiple options that are open for a streaming platform. We can go with a Kafka streaming, or we can go with a Redis streaming. But let me tell you why we have used a Redis streaming rather than a Kafka streaming or a Kafka broker over here. So if you do a homework, you will get to know our Redis streaming platform is super lightweight, and the latency of the Redis streaming platform is quite low than a Kafka broker. Means the latency of the Kafka is more than that of the Redis. And that is why, since here we are creating a chat service, and here the minimum latency is quite crucial, and that is why we are using a Redis streaming platform rather than a Kafka stream. And what it will do? Here we will simply send all the messages that we are getting from the front end. And here in the Redis, we have the concept of the channel. Just the way we have the concept of the topic in Kafka, similarly in Redis streaming, we have the concept of channels. Means each and every chat service will get subscribed to a particular channel that we have over here. So here, since the user 1 is trying to send a message to this user 4, what will happen? This chat service will send the message to the channel where user 4 is subscribed. And where user 4 is subscribed? User 4 is subscribed to WebSocket 2. So here the message will go to the channel 2, since user 4 is subscribed to that. I hope this is clear. So what is happening? All the messages are there within our Redis cluster, but we have to persist it in our database. And for that, what we have to do? We have to write a consumer service to consume all the messages from here and post it into our ChatDB. So here we will write another service called as a message service. And this message service will submit all the data into our chat database that we have defined over here. So all this data will come to the ChatDB that we have defined. I think this is clear. So here all the message is first coming to this Redis, and thereafter it is getting persisted in our ChatDB with the help of this consumer service, that is the message service. Now let's see how this ChatDB will look like. So if you understand the problem statement, this chat service should be highly write heavy, means whatever the thousands and thousands of chat that get submitted within this Redis should get persisted within this ChatDB also. And that is why this DB should be highly write optimized. And the best write optimized database that we have is the DynamoDB or the Cassandra database. So here we are having the ChatDB, and this will be a Cassandra database. And now let's see how the schema will look like. So this is how the schema will look like. Here we have a chat ID, a message ID, a sender ID, a receiver ID, the message, the type of the message, the timestamp, and the delivery status. So you must be confused that what is the difference between the chat ID and the message ID. So chat ID is nothing but one-to-one mapping, means user 1 is connected to the user 4, so that is chat number 1. Similarly, user 1 is connected to user 3, that is chat ID 2. So that is basically the chat ID, and whatever the message that you are typing within the chat is nothing but the message ID. So I hope this is clear, and obviously this also need an auto increment ID, and here we can provide a UID or a UUID over here. And here you can see I have also mentioned the type, that it can be a text message or a image message over here. Now how we will send an image message, that we will discuss shortly, and also how we will update this delivery status, that we will also look very soon. Now let's go to the another main important thing is like, for example, you want to send the message from user 1 to user 4, and user 4 is right now offline. So if you know the feature that once you get a message from your friend and you are offline, you get a notification into your message. So somehow we have to send a notification to all the offline user that you have received a text message. So what will happen? Once the user 1 sends a message to user 4, if the user 4 is not active at that time, we will simply send a notification to user 4. And for that we need another service here as a notification service. And since here we are developing a mobile application, so we have to support both Android as well as for the iOS device. So FCM stand for Firebase Cloud Messaging, and APN stand for Apple Push Notification Service. So this supports Android and this supports iOS. I hope we are almost clear with how we are sending message from one friend to another. Now the next thing that we will see is how to send the group messaging. So let's see, and let's go into the deep dive analysis of how we have to send the group messaging with the same schema structure or the same design structure that we have done till now. And believe me, if you have understood a bit that how one-to-one messaging is happening over here, implementing or designing the group messaging is pretty straightforward. So what happens in the group messaging is like, for example, this is user 1, and the user 1 is trying to send a message to a group. So what actually happens in the backend is like, once the request comes to this chat service, the chat service in turn makes an API call to this group service to see that who are the members that are present within the group. And if you have remembered, for that we have created this group service that is based on a particular group ID. It will retrieve who are the member of that group, means what are the user ID of those members present on that group. And once we have the complete list of all the user IDs that are present within that group, what we have to do? We have to actually individually send that message to each and every member of the group. So it might look from the front end that it is just like a simple broadcast to the group channel, but actually it doesn't happen. What actually happens is individually we have to send message to all the members of the group. Because if you look carefully to the interface of the WhatsApp application, there you can see which are those members who have read the messages, who have not received the messages, and who have received the messages but not read the messages. So to give that amount of precise information, we have to send all the messages to each and every individual that are present within the group. And how we do it? It is very simple. Once the group message comes to our chat server, means here we make a call to this group service. which will return all the list of users that are present within the group. And based on the total number of users, we have to keep an iterator over there, and based on that user ID, we have to check that whether that user is active or not. And if it is active, then it will be present in our WebSocket registry. And thus, taking the WebSocket connector from here, we have to send that message to that respective client or the respective user. And if that user is offline, then what will happen? That entry will not be present within this WebSocket registry, and thus it will get persistent in the DB using this flow. Means it will go to the Redis stream, and from this Redis stream it will get consumed by the message service, and there will be a push notification that will be sent to that user. I hope this is clear. So in case of a group message, both the scenario can happen. Means some of the user will be active, whose WebSocket connection we will receive from this WebSocket registry, and few of the members will be deactivated and will be away from the network. And for that, to implement that offline support, we have to save it in the database. I think this is clear that how with the help of this one-to-one messaging service, we are implementing this group support. Now let's see some different aspect of this messaging, that is how to send an image or a video in the message. So remember, whenever you are sending an image or a video in our messenger or in the WhatsApp service, there the data is not get uploaded in the backend with the help of the WebSocket. Rather, what happens, it follows the same uploading fundamental that we do for our image upload for our website. Means it gets uploaded with the help of the API call. Means whenever you are sending an image or a high resolution picture, that file gets uploaded in the backend with the help of a file uploader service. So what happens is like, once you upload an image, the request come to this load balancer, and here this load balancer will call a image uploading service. So here we will be having an image or the media upload service. And this media upload service will be responsible to upload any high quality image or a video into our server. And obviously, as you know, we do not store any high quality images or the video in our normal database. What we do, we use a blob storage for that. And thus, this data will get persisted in a different storage mechanism, which is nothing but a blob storage. Thus, here we will consider a S3 bucket to store all the images and the video that we are uploading in our backend server. And what happens in the response? Once the video gets uploaded successfully or the uploading process begins, this media upload service will return an image URL of this S3 bucket. So the response of this media uploader service will be an image or a video URL. And once the user or the client receive this video or the image URL as a response of the video upload, that URL actually get persistent in our ChatDB using this service. Means once the video gets uploaded in our backend in the S3 bucket, a simple message request will go with the help of this WebSocket. And here in this case, instead of this message, what we will send? We will send this image or the video URL, and thus this will get delivered to the client where we want. Means in the chat database, here you can see, here I have given the attribute called as message. So this will consist of the image or the video URL. So this can be a text message, or it can be an image or a video URL. And here in the type, we will mention it accordingly. So here we are almost done with everything. Now, the next feature that we have to do is like whenever you are opening a particular chat, you can see there at the very top end, you will get a provision to search a particular message within the chat. So we have to provide a search service so that a user can search a particular keyword or something to search a particular message within the chat. And to implement that, obviously we need a search service, and here to search a particular keyword from this billion of messages, obviously we need a Elasticsearch. So here we will define another service, a message search service. So here the request will come to this message search service, and from here it will call a Elasticsearch that we have over here. And this Elasticsearch will query the chat database that we have over here. So whatever the message we have within the chat database, this will be read by our Elasticsearch, and thus it will give the response based on the keyword. And how the data will go from the chat service to the Elasticsearch, I hope you know that right now by seeing all my previous video, that is with the help of the CDC pipeline. So I think that is clear. And also remember, this chat or the messages that we are retrieving over here might consist of images or the video. So this search service also have to talk to this blob storage to retrieve the corresponding video or the images from the server. Now, there is a small bit of optimization that we have to do. That is, for each and every time the video or the image that we are getting in the display, we cannot pull it from our backend. So to optimize that, to save the latency of this one, what we have to do, we have to implement or we have to introduce a CDN. So as you know, what is CDN? So CDN is nothing but a server that is present geographically into your location, so that whatever the image or the video or the media file or the codes are present nearby to your location, so that the time to fetch the data get minimized. So here what we will introduce, here we will be introducing a CDN library. So all the user will first connect to the CDN library that to see that whether the images is present on the local server or not. And if there is a miss on the local server, means if it is not present on the CDN, then a round trip will happen from the CDN to this S3 bucket, and thus our CDN will get updated. So I hope this is clear that how we have introduced a CDN over here to reduce the time to fetch a particular image or the video in near real time. Now one more thing, that is, for example, you opened your WhatsApp application. Now you want to scroll down all the messages that are there in the history. So what you have to do, we have to fetch it from our backend. And for that also we will be using the same service, that is the message search service, which will retrieve all the previous messages for a particular chat. So here if you remember, we have created an API endpoint, that is this one, to fetch all the messages for a particular group, and the message used to come in the form of the lazy loading or the pagination. Similarly for the one-to-one messaging, the same thing will happen. Means once the user want to fetch the old data, it will come to the user with the help of this service, that is message search service. But there is one thing, that is WhatsApp claims that they do not persist any data for the user. Means according to them, they do not have a database in the backend which persists all the message or information. So how do they do it? Gimmick. But yeah, how we can do it is like, here if you see, we have the user service, and these user are nothing but a client. So, and each and every client is nothing but a mobile device. And within the mobile devices, we have the local cache within the memory. And it is possible that all those messages are persisted locally within the WhatsApp folder with the help of some storage mechanism. So if you are familiar with the Android development, there we have the provision to save some messages in the local. So maybe with the help of that feature, they keep on saving all those information in the local memory, so that the fetching time of the previous record or the fetching time of the messages decrease significantly, because obviously at that time you do not have to make an API call to retrieve the previous information, and because all the information or all the messages are there in the local. So at that case, we do not need a message service to fetch all the information that is not present. I hope this is clear that how we can optimize this also. But here if you just want to remove this chat database completely, obviously this is not possible, because all those unsent message means those messages which need to be sent for the user who are not active at that moment have to be saved somewhere. So it cannot be saved for an undefined amount of time in a Redis stream. So it have to be stored somewhere, and for that we have to use a chat database in the backend. But it might can happen that once the message has been sent successfully to the user, once they are active, at that time we will delete that message from the database. But that is the way to optimize the database, but I'm not sure how they do it in the backend. I hope this is clear that how we can get rid of the chat database, or how we can reduce the size of this chat DB, because obviously there will be trillion and trillion of messages, and if we keep on persisting all the messages, that will be a huge load for the backend. So I have pretty much covered everything, but let's go a bit deeper, because there are a few more functionality that are still pending. And that is number one, how we will show it to the user that a particular user is online or not. And if you have understood this designing properly, you can easily understand that whoever is active on a particular instance of time, for that user, the WebSocket connection should be also active. Means his entry should be present on this WebSocket registry. And if the entry is present on this register, then we will say that that user is online. And as soon as this user gets offline, means after some time, once this tutorial is over, obviously the record will get deleted from here, and based on that we can showcase that this user is not active and it was active till a particular time frame. And how we will get that time frame? That is, we have to update this last seen variable that we have within the user database. So what we have to do? We have to make a connection between this user database and between this Redis cache. And how we will do it? We will also implement a CDC pipeline over here, so that whenever there is a change over here, means whenever there is a timeout that happens for a particular WebSocket connector, here we will send a notification to our user management service that this user is not active over here, and thus here you just update the last seen over here for the user. So I hope this is clear. So here we will be having a user management service, and this user management service will update the user status, means whether he is online or not and what was the last seen of that user. So here with the help of this WebSocket registry, we can track a particular user. Now at the very end, there is a small bit of piece that is still pending. That is, for example, a user is offline, and once he comes online, how we could retrieve all the messages, or how we can retrieve all the unsent messages for the user. And for that, what will happen? Once the user gets a WebSocket connector over here, it will go to the chat service, and this chat service have to call that whether there is any pending messages for this user or not. So here we will be having one more service called as another message service. And this message service will fetch all the messages, means all the unsent messages from this ChatDB. So this will retrieve all the unsent messages, and obviously all the messages will have the sender ID and the receiver ID. So we can easily find out who have sent the messages, what is the message type and all those things. So it is pretty straightforward. So here if you look carefully, we have almost covered everything that we have taken into consideration in our functional requirement. The only thing that is pending is like we have to give the delivery and the read receipt. So that is quite simple. That is, here, whenever you are using a WebSocket connection, using that WebSocket connector only, you can easily give an acknowledgement that whether you have received the message or not. Means when the server is sending a message to the client, it can simply get a acknowledgement that it have received the message. Means it will be a double tick, and once the user have opened the message, then the front end have to send another notification to the backend, means to the server, that that message has been read, and thus it will mark it as double tick, and thus here we will update delivery status to read, means it is successfully delivered and the status is read. So here we have covered each and everything that is required more or less to create a WhatsApp application or create any chat application for your system designing. So I hope you have thoroughly understood this video until now. So just to give you a simple understanding of this complete architecture, let me tell you in short that how the data flow will work. So let me give you a data flow diagram of the steps so that it will be very easy for you to understand that how the connection are getting established, how we are retrieving the messages and how we are sending the message. So let me give you the data flow of this designing. So this is the complete data flow of our designing. So I will request you to pause this video over here and go through this entire steps one by one, so that it will be easy for you to understand by yourself that how the data is flowing across the application. And after that, I will explain you how the entire system is behaving. So the first thing that is happening is like, once a user comes to our WhatsApp platform, it have to first register to WhatsApp. And for that, to register that user, we have this user service. So with the help of the user service, we are onboarding a member in the WhatsApp community. Next, what we have to do? Once the user logs in with their credentials, means with the phone number, then what is happening? The first thing that is happening is like the call is going to our backend application, and our backend application is checking that whether there exists an open WebSocket connection for the user or not. And we are using this Redis cache or the WebSocket registry to get that information. So if the user is coming for the first time or he is coming after a long time, so obviously there will be no active open WebSocket connector. And if it is not present within this registry, then what is happening? The same HTTP request will get converted to a WebSocket connector. And once it gets converted to a WebSocket connection, an entry will get inserted within this registry. That is the mapping between the user ID and the WebSocket connector that got established. So right now our user 1 is successfully logged in into our WhatsApp environment. So the first step that happens is like the establishment of the WebSocket connector. And as soon as that is done, what we have to do? We have to check whether there is any undelivered message for that user or not. And for that, what will happen? The call will go to a chat service, and this chat service will call this message service to retrieve all the undelivered message for the user 1. So it will scan this entire ChatDB and it will try to retrieve all the unsent messages with the help of the user ID and the delivery status. So this message service will retrieve all the unsent message and it will simply return those messages with the help of the WebSocket connection to user 1. And as soon as the message got delivered, another acknowledgement will come from the client, means user 1, to update the delivery status of that messages to double tick, means the message has been sent successfully to the user. And thus here the status will change from unsent to sent. Now as soon as the user 1 opens the chat and read the messages, another acknowledgement will go via WebSocket connector into the chat service that the message has been read successfully, and thus we have to change the delivery status from sent to read. Clear? And all this data is flowing across this WebSocket connector through this Redis stream. So we are right now done with onboarding our offline user into our application. Now what is the next step? The next step is he will start the conversation with the friend. And for that, what it will do? It will simply send a text message to his friend. So using the same WebSocket connection, it will send a message to his friend, for example, user 4. And as soon as the message is received by the chat service, the chat service will see that whether user 4 is also active or not. And if he is not active, what it will do? It will send it to the Redis stream to the offline channel. Means these users are offline right now. And once the message gets sent to this offline channel, two things will happen. Number one, this message service will consume that message and will persist it in our chat database. And number two, a notification message will go to that user that you got some new message in your inbox. Clear? So this is how we are managing that, how to send a message to a person who is offline. Now let's consider that the person whom you're trying to send the message is online, and how we can determine that whether the receiver is online or not. We can easily do it with the help of this WebSocket registry. And if the user is online, what we have to do? We have to check that which WebSocket connector it is connected to. And based on that, we have to push the message to the Redis stream to that channel. So for example, the user 2 is present in this chat server and it is subscribed to the channel 4. So here the message that has been sent by user 1 will go to the channel 4 of the Redis stream. So that this chat service where user 2 is located can consume the message from this channel 4 and can send it to the user. And as soon as it gets sent to the user, we have to also send an acknowledgement to the user 1 that user 2 have already received the message. So all this acknowledgement will be done with the help of this WebSocket connection. Now what next? That is how we can send a group message. And the way we send a group message is pretty easy. That is, here, instead of sending the message to a particular individual, we mention the group ID where we are trying to broadcast the message. And here in the place of the user 4, we will have the group ID. And what this chat service will do? The chat service will call this group service to get all the list of users that are present within this group, and based on that it will again do the same thing, that is fetch all the user ID from that group, and then it will check the availability of the user using this WebSocket registry. And if the user is available, it will then and then the message will be delivered to the user. Otherwise it will get persistent in the DB and it will be marked as unsent. So this is how the entire thing will happen. And obviously all these messages will be sorted with the help of the timestamps so that the user get a synchronized message in the front end. I hope we are clear and we have thoroughly understood that how we should implement a WhatsApp or a chat messaging service with this video. And if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my channel and you are always ready for your next interview. So see you on our next video. Thank you.